and gentlemen, good morning. As you've heard, my name's Kit. I'm part of the Energy Renewals team. I'm the newest and youngest member of that, as you can probably tell. I've only been there approximately 2 months now, so this is completely brand new to me talking to people like this. And I'm sure Ken won't mind me saying that this is my first proper office job. My only previous experience has come from Ricky Gervais, so we'll see. So in my time here, I use lots of data, and I've learned to use that data for three main things. It's understanding and collecting, it's managing portfolios, and ultimately, it's finding savings for our customers. And we call this smart billing. I'm now going to introduce you to Dan, and Dan will explain further about what we use this data for. Thank you very much.
Good morning, everybody. You don't have to forgive me because in my spare time, I'm a rock star. So when I say I'm used to kind of, good evening, everybody, hooray! So we want to liven the room up a bit. And Kit there, I think, isn't used to talking in front of a lot of people. So that was well worth a round of applause. Yes, I'm Dan. I actually work for a company called Measure My Energy, and we are the manufacturer of the technology behind Energy Renewals smart billing service. So I want to talk a little bit about that and the principles of it. I guess, broadly speaking, room full of facilities managers or thereabouts. We've got probably two schools of thought in the room. There are those that believe you can't fatten a pig by weighing it, and there are those that believe you can't manage what you don't measure. And naturally, I'm here to appeal to the latter. This is what we're all about, a bit of measurement. Because in your businesses, if you are looking to manage costs and reduce costs, I suppose energy it's regarded often as a necessary evil, isn't it? You've got any other costs. If you have a higher than expected telephone bill, then the first thing you're going to do is go and scrutinise the itemisation and understand who's calling who and when and why, and understand why that occurred and see if there's anything you can do differently about it. If you have a higher than expected payroll, then you can go and look at every penny of overtime or commission that's gone out the door, and you can understand why that's happened and see if you might want to make any changes. When you get a higher than expected energy bill, you pretty much often just moan about it and pay, right? This is asking a business to use less energy is often like asking a person to breathe less air. It just is. We have to go and do it. We need to use that. But actually, what I've come to learn in this business and doing what I do and working with Ken and the team here at Energy Renewals is that is often, you'll be very surprised, by better understanding when and where and how that energy is being used and that money is being spent, actually you can often develop strategies to reduce it. And I've got a firm working example I want to share with you. This is a genuine client of ours, and this is a look at the shape of their business, a bit of an energy profile. I'm sure many of you have seen very similar shaped graphs, looking at perhaps half-hourly data or understanding how much energy is being consumed by your organisation. We're closed, we're open, we're closed, fairly typical shape of a day for a lot of people. And this particular business kind of said, yeah, we've got the half-hourly data, we know what we're spending and where we're spending it on, there's not a lot we can do about it. We beg the question, so here, this point that we're highlighting here, in the middle of the night, still consuming some 70 kilowatts, spending circa £10 an hour on being closed when nobody's there and no one's doing any work. Well, they say, shrug the shoulders. That will be all of our IT, won't it? It's the servers, it's the air conditioning in the server rooms, it's all of the stuff that we can't turn on. Everybody's got stuff that they can't turn off. It's a fair assumption to make, you might think. So we have a look and we see here is an example. This is just a snapshot. So this is the top 10 offenders, if you like. These are the top 10 energy consuming items in that particular business at that particular time, accounting for some 40 of those 70 kilowatts there. And you can see, absolutely, yes, we've got up here, I can't use the pointer on our remote control, but I don't know if you can read that from the back, but absolutely the air conditioning and the comms room and the servers are all in there. But if we take those out, we're left looking at simply power and lights. This is first floor power, third floor lights, second floor power and lights. Power and lighting in the middle of the night taking up more than a third of their overnight consumption, which is until now been assumed to be all driven by the IT and those items that can't be switched off and are fundamentally necessary to run the business. Significant saving opportunity, cost benefit, carbon reduction, call it what you will. That's a lot of energy being wasted when it doesn't need to be. And that can either be addressed through the implementation of technologies or behavioural change programs, which I know the guys here at Energy Renewals are very much a part of. So using some of this level of information, really understanding and getting under the skin of how and when and where all of that energy is being used and all of that money is being spent, means that those strategies, those behavioural change programs and or decisions about other technology investments can be made with very credible information to back it up. That said, of course, going through all of this data is sometimes a little bit time consuming, and I know that you are all very busy people, so the last thing you want perhaps is to have yet another wood for the trees problem where you can have all of that information in front of you and not really know where to start. So I know that the guys here at Energy Renewals want to talk about how they use the data to work with you and put those programs together. So I'm going to hand over now to Rachel, who... No, I'm not. Yes, I am. I'm going to hand over to Rachel, who's going to talk to you a little bit about that.
Thanks, Dan. So we've just heard from Dan there about how we collect the data. Kit mentioned earlier there are three elements to what we do here at Energy Renewals. The first being data collection, the second being customer portfolio management, and the third being ultimately finding savings. Now that data that we collect ultimately needs to be put to use. And that's where I come in, because my day-to-day job is managing the customer portfolios. We'd like to share with you two further examples today of how we use that data, the first of which is voltage optimization. I'll now pass you over to my colleague Nick.
See, that's how it works. I'll stand over here. Right, absolutely brilliant. Coming from these new guys, first time I've been up in front of a live audience, so to speak. Absolutely fantastic. That it's good to see. I believe it's been recorded and subtitles being added later. And apologies for my northern accent, but there might be some translators in the room that can work it out. My name's Mick Greensmith. I work for a company called Power Efficient Systems, and we manufacture a number of technologies that basically you put in and it saves energy without you actually having to do anything else, which is fantastic, because one of the most difficult things out there is to change people's habits. And there's lots of intelligent equipment and smart equipment you can do to reduce energy. If we could all change our habits, that would be even better in solving the problem. So what is voltage management, and why do we need it? So what it is it controls and stabilises the voltage coming into the building. Electrical energy is something that we're all using. Everybody uses it. And it's actually, we're using more and more of it all the time, and we're relying on less on different types of energy, and we will have to rely even less on the energy such as gas and oil in the future. You will reduce the energy being used in a building by reducing the voltage coming in. It maintains the security of the supply. It actually makes this electrical infrastructure safer and more stable. And we look at targeting the optimum level of voltage for a building, because all equipment has different voltages that it wants to work at most frequently, or most efficiently, sorry. But there is sort of like a sweet point for the building, so we look at getting the sweet point for the building. It was introduced as a power quality measure, but it's now been used as an energy saving measure, because that's the actual added benefit from it. And it extends the life of all electrical equipment, so it reduces your maintenance costs, and it acts like a control valve coming into the building. So why do we need it? 1994 EU legislation came in place. You'll see on any piece of electrical equipment now there's a little mark that says CE, and that means it conforms to European standard. That means that it will work anywhere between 207 and 253 volts. And the sweet spot is somewhere between 220, 225, single phase to neutral, because we have single and three phase voltages. The average voltage in the UK is 242 and rising. Actually, the average voltage on mainland Europe is between 220 and 230, and ours is sort of between 240 and 250. So we're delivering 20 volts more than all the electrical equipment needs. And it means that all our appliances are operating higher and closer to the red line effectively. That means it results in damage to the equipment overheating. Generally speaking, that over voltage is turned into heat and noise and electrical vibration, which generally speaking is not beneficial to the electrical appliances. So just looking at this voltage scale, that's where we are, the nominal voltage here in the UK, around about the 242 mark. That's the maximum that legally there is allowed to be delivered to you. And down here is what the nominal voltage is supposed to be, 230 volts plus or minus 10%. And down here is where most equipment runs most efficiently. So you can see that actually where we are in the UK, we're further away from the middle than we would be if we were down at the bottom of the rest of Europe. So just to put the technical bit to rest, because we sometimes get asked about Ohm's law, this just makes it really simple. A 2 kilowatt appliance is rated at 2 kilowatts at 230 volts. So at 242 volts, it runs at 2,240 watts, and that same 2 kilowatt appliance at 222 volts with a 20 volt reduction runs at 1,881 watts. That gives a saving on watts, and it's kilowatts per hour that we pay our electricity bills in, of 16%. So just to reiterate about the pressure side of things, voltage is very much, there's a lot of expressions in electrical circuitry similar to water, and voltage is sort of the pressure in the pipe. The higher the pressure, the more likely things are to burst. It really is as simple as that. You get words like current and flow, and because electricity behaves very similar to water, although it's not a really good idea to mix the two. The different types of voltage control that we manufacture, and again this depends on the type of building and operation, is we have a fixed tap multi, which is a fixed multi-tap compact unit, which we tend to do up to around about 160 amps. That's if you've got an electricity consumption of 350,000 kilowatt hours-ish, up to that. This is the kind of product that we would put in there. Then we have variable, so when you're over that load, so you're over that 350, 400,000 kilowatt hours, manufacturing processes where things change throughout the day, then we put a stabilised range in. And then for 24-hour operations where voltages vary massively, both up and down, we will do a fully stabilised unit. All of these products would only be done following a full site survey. So when we come and do a survey, we look at the kilowatt demand or the kVA demand. We size our equipment to the size of the operation. You can have buildings that have 1,000 amp incomers but only pull 200 amps, and you might think, oh, I've got to put a 1,000 amp unit in there to match the incomer. What we do is, because our units all come with their own circuit protection built in, we'll match the demand of the building. So we build into it sort of a bit of a headroom, around about 25 to 30% headroom on a unit, to allow for any planned expansion or unplanned expansion, plus anything else that might crop up. We look at the power factor. Power factor is a massive issue within manufacturing operations. And we look at the voltage, obviously, because we want to determine how we're going to set things up. We look if there is planned expansion. We look at other energy saving measures like non-linear loads, where maybe VSDs or inverters have been put in as an energy saving measure, because they have an effect on the amount of savings or reduction that voltage management can have. And we look at the load dynamics. We look at when the equipment's coming on, how long it's running for, what type of equipment it is, can it be switched as well. And from that we then design the unit bearing in mind voltage fluctuation, the current that's been used, the size of supply and the total kilowatt hours. Just in closing on that, just want to say that this technology is not new, isn't voltage management. As a company, we're a UK manufacturer. We've been in business for 15 years, making this equipment. The actual technology has been around for over 100 years. It's very, very reliable and has no serviceable parts other than the normal electrical inspection. So if anyone wants to find out a little bit more, get back in touch with Energy Renewals and we can do your free site survey based on that. So I'll pass you back to... It's okay. I didn't know I was passing back to that.
Thank you.
Thanks,
So I'd just like to introduce you now to our MD Ken, who's going to talk you through demand side response.
Thanks everyone. Unfortunately I don't have a fancy presentation to share with you. I'm just going to run through demand side response and make it dead simple for you. So, okay, I'd like to start by asking you all a question. Does anybody know what demand side response is? Anyone else? Okay, I'm glad everybody didn't put their hand up at this moment in time because that's when I have to pack my bags and go home early. Okay, well, it's dead simple. The National Grid pays companies to reduce their energy consumption at times of peak demand. Businesses are currently earning up to £1 million a year. Well, some are, and surprisingly, some aren't. 95% of UK companies aren't taking advantage of the financial rewards that they're entitled to from the National Grid. Yet a recent poll in The Energist reports that 79% of businesses want to take part. So what's stopping them? The same survey explains the catch. Well, let me tell you the real reason why. It's fiendishly difficult to understand. Having been on many demand side response presentations, there's so much technical information to get your head around. For instance, you've got frequency response, power responsive, non-BM balancing, BM balancing services, store runway, turn up, turn down, turn around, forget that, I've just made that one up. You've got TA trial avoidance, you've got TA transitional arrangements, you've got TA auctions. Who could possibly keep up with all of that? This is where our team comes in. They understand the detail of demand side response so our customers don't have to. And more importantly, so I don't have to. My focus, if I'm to take you back, is on the third element that Kit and Rachel spoke about. The first thing we do is to collect data. Second, we use that data to manage our customers' energy portfolio. The third, the end result, is to report the savings we've made. At this point, you're probably wondering, how much savings? Good question. Well, it varies from customer to customer. But in the last 12 months, our team have delivered between 12 and 44% on a customer's annual energy spend. I'm sure you'll all agree with me. That's very impressive, isn't it? And what more, the team, Mick, Dan, Kit, Rachel, Sam, Graham, and everyone back at the office, not David Brent, work hard every day so we can save our customers even more. Thanks very much. We've got a short video to run through demand side response.
Did you ever think your business energy could earn you smart money and still be green? The National Grid is enabling smart companies to earn anything between 27k to £1 million a year. The National Grid temporarily turns on old, inefficient and expensive carbon-intensive power stations to meet the peaks in demand. New technology can put a stop to this. The National Grid is now able to harness the spare capacity of power between 30 to 40% by temporarily switching off non-critical systems or turn on standby generators and redirect it to where it is needed. So the old, inefficient, dirty power stations can be turned off. And you can help to greatly reduce carbon by using the most effective way of delivering green, cheap energy to the UK. Best of all, the National Grid pay your business to be a virtual power station.
Thank you for listening. Thank you very much.